Hi, welcome to Cracking MBA. Today we are going to talk about some advanced concepts in remainders. This is part of the numbers chapter. What we will discuss today are some of the concepts in remainder theorem method, and also we'll look at how to identify the remainders when we have a sum of two numbers, large numbers, and the multiplication of two large numbers. So we've seen in another video called remainders basics, or it's just called remainders, where we have seen the direct division method and the pattern method. In this video, we are going to look at the remainder theorem method. So the remainder theorem method basically states that if a function f of x is divided by x minus k, then the remainder is f of k. Now let's look at an example. If we see on the right side, we can find that if f of x is equal to x squared minus 7x plus 12 is divided by x minus 3, then what is the remainder? So here the function is f of x and it is being divided by x minus 3. So f of x is nothing but x squared minus 7x plus 12 and it is being divided by x minus 3, which is in the format which is stated on the left. So the remainder is nothing but f of 3. So just substitute the value of 3, you will get the remainder. So it is nothing but 9 minus 21 plus 12 is 0. Now this can be verified because x squared minus 7x plus 12 can be written as a multiplication of x minus 3 into x minus 4, and since we are dividing by x minus 3, which is one of the factors, it is clearly divisible and the remainder is 0. So let us now look at how we apply this. So what we are saying is, what is the remainder after the division of 2 power 78 by 7? Okay, now 2 power 78 is a large number. We can solve this question by pattern method as well, but let us see how we can solve using the remainder theorem method. Now we need to express 2 power 78 as f of x, and we need to define 7 as x minus 8 or x minus k. So basically 7, which is the divisor, can be expressed as 2 power 3 minus 1. Now if 2 power 3 is the value of x, then 2 power 78 should be represented in the form of 2 power 3. Okay, so 2 power 78 is nothing but 2 power 3 multiplied by 26. So now we can replace 2 power 3 as x. So what will it become? We can write f of x is nothing but 2 power 3 power 26. So 2 power 3, if you replace by x, it becomes x power 26. And this we are saying is being divided by x minus 1. Okay. So the remainder will be f of 1, which is 1 power 26, which is 1. Therefore the remainder is 1. Let us now see another question, similar. What is the remainder after division of 2 power 78 by 9? So here we are saying division by 9, earlier we said division by 7. So 9 can be expressed as 2 power 3 plus 1. So similarly, just as we saw in the previous question, we can assume 2 power 3 as x, and therefore 2 power 78 can be written as x power 26. But here the difference is that 9 is equal to 2 power 3 plus 1. So if 2 power 3 is x, we are saying f of x is divided by x plus 1. Since we want to find the format of x minus a, we should say 2 power 3 minus of minus 1. So the remainder will be minus 1 power 26, which is 1. So therefore the remainder is 1. So this is how we rewrite the the question or the number in the form of f of x, which is 2 power 3 to the power of 26, and also the divisor in the form of x minus a, which is 2 power 3 plus 1. Now let us look at a different divisor. What is the remainder of division of 3 power 78 by 10? Now this is also similar. We just need to identify in the form of f of x. So here the divisor is 10. We can write it as 3 power 2, which is 9 plus 1. So 3 power 2 is assumed as x, and we need to find f of x. So f of x is nothing but 3 power 2 power of 39. So here the remainder is going to be minus 1 power 39, which is minus 1. Okay, but now the remainder cannot be negative, right? So we add the divisor to the remainder to get the remainder. So here minus 1, which is plus the divisor, which is 10, we get 9. So 9 is the remainder. Okay. Now, which method should we use? Out of these three methods, when the number is small, go for the direct division method. When the number is large, for example 2 power 78, go for the pattern method or the remainder theorem method. However, for the remainder theorem method, you need to identify the function in the form of f of x and then identify the divisor as x minus a, and then we can use that. But the pattern method is way simpler, and all you need to do is just identify the pattern for each subsequent power of the number. So try to use the pattern method as much as possible, and if you're not able to identify a pattern, then go for the remainder theorem method. Now let us see another advanced concepts. So how do you find the remainder when you have sum of two large numbers? Okay, so when we are asked the sum of two large numbers and asked to find the remainder after division by another quotient, the remainder is nothing but the sum of the individual remainders. Okay, so let us see and look at an example. So what is the remainder after the division of 2 power 36 plus 3 power 36 after dividing by 10? Now we have two large numbers, 2 power 36 and 3 power 36. So here let's apply the combination. So let's do the pattern method for 2 power 36 divided by 10. We get the remainder as 6. And to know how to apply the pattern method, you can look at the other video on remainders on our YouTube channel, or you can check out our Android app as well. Now applying the remainder theorem method that we just discussed, for 3 power 36 divided by 10, we get the remainder as 1. So the final remainder is nothing but the sum of these two remainders, which is 6 plus 1 is equal to 7. Now if it so happens that the remainder is greater than 10, then again you need to divide it by 10 to get the remainder. Now what happens when we do the product of remainders? So just as this is sum, product is also the multiplication of the individual remainders. So here again the individual remainders are 6 and 1. Okay, for 2 power 36 multiplied by 3 power 36 by 10, the individual remainders are 6 and 1. We multiply both of them, we get the remainder as 6. Now again, similarly, if the multiplication is greater than 10, then you again divide that multiplied value by 10 to get the remainder. Now let us solve some CAT questions. So what is the sum of all the two-digit numbers that give a remainder of 3 when divided by 7? So this is a CAT 2003 question. Okay, so this is a combination of the multiple concepts of remainders and progressions. So let the two-digit number be in the format of 7q plus 3. So this is what we saw in the remainders basics video. Now the first two-digit number is 10, and hence the values of q is 1, and the last two-digit number is 99, but the number which fits 7q plus 3 format is 94 for q is equal to 13. So basically you have 13 numbers from 1 to 13. Okay, and if you substitute the values, you will get 10, 17, 24, so on up to 94. Now this is a simple arithmetic progression, and the sum can be found as n by 2 into a plus l, which gives 676 as the sum. Okay, so typically you may not just get direct remainder questions. You might have to apply multiple concepts to get the answer to this particular question. So this is a CAT 2003 question. Now let us look at another question from 2005. If x is equal to 16 cube plus 17 cube plus 18 cube plus 19 cube, and that is divided by 70, then what is the remainder? So here you might tend to look for pattern method, or you might tend to look for the remainder theorem method, but sometimes it may not just be possible using those approaches as well. Let's look at a different approach. Okay, here we make use of the formula called a cube plus b cube is equal to a plus b into a squared minus ab plus b squared. So we need to group together 16 cube plus 19 cube and 17 cube plus 18 cube, which will give you in this format. Okay, 35 into this product, 35 into this product, and this whole product is a multiple of 2, and this whole product is a multiple of 2. So we get 35 into 2k format, which is a multiple of 70. Hence the remainder is 0. Now let us look at another CAT 2004 question. So what is the remainder on dividing 15 power 23 plus 23 power 23 by 19? Okay, so this is an interesting question. So we can express 15 as 19 minus 4 and 23 as 19 plus 4. Okay, so if we expand this, we will get an expression which is a multiple of 19. So we can write f of x is equal to a big expression which is 19 power 23 plus 23c1 into 19 power 22 multiplied by 4 and so on. So this 19 plus 4 power 23 can be expressed as 19 power 23 plus 23c1 19 power 22 multiplied by 4 and so on. So that whole function can be expressed as a function of 19. So here if you want to apply the remainder theorem divided by x minus 19 minus 0, the remainder will be if you set all the values of x as 0, or if you f of x, the x is equal to 0, where f of x is of and then we will get the all the expressions on expanding, all the expression will be having power of 19, whereas the only last two, which is minus 4 power 23 and plus 4 power 23, which is what you will get on applying the remainder theorem as well, you will get minus 4 power 23 plus 4 power 23, which neutralizes to 0. So the remainder is 0. So that's it for some of the advanced topics, concepts in remainders. Please brush up your concepts again, and you can attempt the mock test on the remainders advanced concepts in our mobile app.